Hello and welcome to Gantavya JEE classes. I'm going to discuss a question from JEE MAIN 2023. So when a student asked me this question, he said that he saw the solution, but the solution is quite lengthy. Is there any alternate approach to solve the question? So in JEE MAIN 2023, they asked this question. Definitely the question is based on quadratic equation, and it would be the case that we will not evaluate the value of the required expression by directly putting the values of alpha and beta, because alpha beta will either be irrational or imaginary. They will not be simple straightforward integral values. So let us first check the discriminant of the equation. Look, discriminant is b square minus 4ac, so it's going to be negative. So the roots are imaginary. Now we have to see what kind of manipulations are required to solve the question. One option will be that you find alpha and beta, roots will be imaginary, and then somehow put the values of alpha and beta into the required expression. Maybe you will convert those values into polar form because such a high power 23, power 14 cannot be directly evaluated. So that could be one method. And the solution which were present in the books, I saw for a few resources for the solution. So I came to know that method one to solve this question was this. This was method one to solve the question. I found this solution in a book. Definitely it is lengthy, quite lengthy. Here they converted values of the roots alpha beta in polar form, and then they simplified the higher powers of alpha and beta. I got one more solution in another book, and the solution is this. It seems to be little less lengthy, but again they used complex numbers here. They converted alpha beta into polar form, and then they tried manipulating the expression, and then they tried finding the higher powers of alpha and beta. So let us check whether there is another solution to solve the same question or not. So I worked upon the problem and I came across a third solution, which is based on some manipulation, but I feel that that solution will be more interesting and not such lengthy solution. Okay, so let us solve this question. Now, first find the roots of this equation, which are alpha and beta. Roots are coming as root 3 by 2 minus 1 plus minus iota, so roots are imaginary. And we know if coefficients of the equation are real, then roots, if imaginary, will always occur in conjugate pairs, as is the case. Now we need to find the value of this expression alpha to the power 23, alpha to the power 14. So higher powers of alpha and beta are involved here. So I thought that let us take a particular root here. Let me assume that any one of these roots is alpha. So if I find alpha, let us assume that alpha is root 3 by root 2 and minus 1 plus iota. I thought that this minus 1 and iota, I have seen such kind of numbers before. In complex number, if we square this quantity, it is going to be a purely imaginary number because 1 square and iota square are going to cancel each other. So with that analogy, I thought that let us square this. So alpha square will become 3 by 2, and with a plus b whole square or a minus b whole square, I will get 1 and minus 1 for iota square, they will cancel each other and I'll get minus 2 iota. So finally I got minus 3 iota. This is alpha square. Similarly, if I square the other root, definitely it's going to be plus 3 iota. Why? Because both the roots are conjugate of each other, so their squares will also be conjugate of each other. So we are getting minus 3 iota and plus 3 iota. Immediately looking at this, I can say one thing. I can say that if I add the two, alpha square plus beta square is 0. Actually, I thought of creating a higher power, but I started with power 2 because squaring will give you a purely imaginary number. Now, this expression can also be written as alpha square equals to minus beta square, and I thought that let us take power 7 on both the sides. So if I take power 7 on both the sides, 7 is an odd number. On left hand side, you will get alpha to the power 14. And because you are raising power 7, which is an odd number, negative remains negative and beta raised to the power 14. Now, if you take both the terms on left hand side, alpha to the power 14 plus beta raised to the power 14 is equals to 0. And I think I can use this information directly into the given expression. This part is going to be 0. Similarly, look at the denominator. We also have alpha to the power 10 plus beta to the power 10. So if I again raise a power 5 on both the sides to this equation, I will get alpha to the power 10 equals to minus beta raised to the power 10, which again gives me alpha to the power 10 plus beta raised to the power 10 equals to 0, which again can be used in the same expression. So this term is also going to be 0. So somehow I am able to reduce the length of the given expression. Now this given expression becomes alpha to the power 23 plus beta to the power 23 upon alpha to the power 15 plus beta raised to the power 15. Still, power 23 and power 15 are here in the expression. Now I observed that the difference between the powers 23 and 15 is 8. So I thought that let us again find alpha to the power 8 and beta to the power 8. Look at this. If I again raise power 4, alpha square is minus 3 iota. So if I raise power 4, it becomes alpha to the power 8 and minus becomes plus. So 3 to the power 4 becomes 81 and iota to the power 4 becomes 1. Similarly, if I raise beta square to the power 4, it becomes beta raised to the power 8. And on the right hand side, I again get 81. So I think value of both these quantities, alpha to the power 8 and beta to the power 8 is same. So it is advantageous for me to use it here in numerator. So in numerator, I can write alpha to the power 23 as alpha to the power 8 into alpha to the power 15. Why this bifurcation in 8 and 15? Just because denominator has a power 15 plus beta to the power 8 in the same way can be written as beta to the power 23 can be written as beta to the power 8 into beta raised to the power 15. Whole upon denominator remains as it is. Let us keep the denominator as it is. Now, as we have derived, this alpha to the power 8 has a value 81 and beta to the power 8 also has a value 81. So I put this value that 81 is taken common. In bracket, we are left with alpha to the power 15 plus beta raised to the power 15. And the denominator is also same, alpha to the power 15 plus beta to the power 15. So this entire term is cancelled without finding its value. We got our answer is 81. I feel that this solution is quite intuitive, means it is based on some logical reasoning. You have to recognize few patterns between the numbers and write the solution. Hope you like this video. If you find this solution interesting, don't forget to like, share and subscribe the channel. Thank you so much.